Okay, so we're going to go ahead and get started. So welcome to the afternoon session for our 5th UC Data Day. Welcome everyone. Just a couple of logistics for people to make aware of. The session is being recorded and we will make the recordings available on our UC Data Day website afterwards. We ask that if you could go ahead and introduce yourself, put your name in the chat and your institution that you're affiliated with and the department that you're coming from to say hello to the other participants. If you have any questions during the sessions, put them in the chat. We have moderators that will be watching the chat and they will either directly answer your questions or they will ask the presenter to respond as well. So next slide, please. Okay. As you may have noticed, we have American Sign Language interpreters with us today. They are spotlighted, so they should appear on your main screen. If you want to pin them for yourself, we've put their names on the slide, Jessica Fry and Jessica Minguez. And if you also search for interpreter, you'll be able to find the names. We are going to add closed captions afterwards to the video when they go up on our website. We are hoping that today's event is a welcoming event for everyone participating in the spirit of learning and exploration. We ask that we be kind and respectful and courteous of other participants so everyone can have a great day today. So this is our agenda. We're going to have a day-to-day welcome from Xuemao Wang, Dean and University Librarian, and then we'll have a keynote with Glenn Ricart from US Ignite, and then an interactive panel discussion with our keynote speaker. Okay, we are asking you to participate in an activity with us today. We are going to be putting a link in the chat throughout the keynote presentation. And we want to hear from you. What are 3 words that you think UC should focus on while thinking about the future of data? So the bit.ly chat link is going into the chat. If you just click on it, it's going to take you to a Google form and you can fill out the 3 words. This is completely anonymous. We are going to create a word cloud and show you that word cloud a little bit later in our presentation. So with great pleasure, I'd like to ask Xuemao Wang, Dean and University Librarian, to give some thoughts for the day and to introduce our keynote speaker. Xuemao, the microphone is yours.
Thank you, Amy, and good afternoon, everyone. Again, my name is Xuemao Wang. I'm the Dean of the Libraries and also the Vice Provost for the Digital Scholarship. Welcome, everyone, to our 5th Annual Data Day. For the past 5 years, UC Libraries, along with the IT at UC, the Office of Research and the Office of the Provost has hosted the Data Day to educate, to share ideas, tackle challenges, and celebrate advancement in the data and the research. We have reached out to greater Cincinnati communities and brought in many times participants beyond the UC. This year will be our first virtual Data Day with the theme, How Data Will Change Our Future. It is the topic that seems particularly appropriate for today. Over the past 8 months, data has played an important role in the global COVID-19 pandemic world. It is guided the decision-making of the world leaders and being the backbone for individual scientific researchers. Data is the future. It has the ability to shape the world, to create better outcomes. I'm excited to spend some time today with all of you to explore it together. At UC, data-related activities has been entrenched in many universities' core missions of learning, research, and community engagement. A few examples I want to mention here. To fight the pandemic, UC created the COVID-19 data dashboard with multiple data sources fed from local and statewide health data systems. to increase our research computing capacity, UC established an Advanced Research Computing Center, known as ARC, a high-performance computing infrastructure that supports and accelerates the computational and data-enabled research, scholarship, and education across the university. Recently, our College of the Business, Nenner College, launched a series of the data science speaker panels symposium over the month of October and invited speakers from multiple sectors of the industry. Last but not the least, at the UC Libraries, our Digital Scholarship Center, DSC, received second renewed grant from the Andrew W. Mellon Foundation. With this 700,000 grant, we will pursue our data-driven machine learning and data visualization digital scholarship research initiatives. Very soon, you will hear my announcement about a new organization we're merged with the DSC, Digital Scholarship Center, and Research and Data Service Unit, known as the RDS in the library, which is the unit co-hosting today's event. United, they will lead data day planning as one unit to pursue our enterprise-wide digital integration vision. Now, I'd like to thank the Research and Data Service, Research Computing Service, and Accessibility Resource for their support for today's event. A special thanks to the Data Day co-chairs, Jim Combs and Amy Koshoff, and the Data Day Organizational Committee members, Tiffany Grant, Amy Latassa, Melissa Cox Norris, Rebecca Olsen, and Jason Nard. Thank you for all your hard work to organize today's event. Certainly, another special thanks goes to our keynote speaker and panelist for joining us today. Now, I'd like to introduce our today's keynote speaker, Glenn Ricart. Glenn is the founder and the CTO of US Ignite. Dr. Ricart has a wide range of experience in innovation, from academia, federal agency, large and small corporate experience. He has been a pioneer implementing the first internet interconnection point, known as FIX in the College Park, Maryland, and the first institution-wide TCP/IP internet network in 1983. Glenn was the principal investigator for the SuraNet, the first regional TCP/IP internet network of academia and commercial institutions. Dr. Ricart worked as the executive vice president and the CTO for Novell in the 1990s, managing director of PricewaterhouseCoopers, and CEO and president of National Lombardy Rail. He has been the founder and co-founder of 5 startups. His inventions has resulted in more than a dozen patents. Dr. Ricart has served on the boards of 3 public companies, CACS, the SCO organization, and the First USA Financial Services, in addition to numerous of non-profit boards. Now, please join me in welcoming Dr. Glenn Ricart. Glenn, please.
Well, thank you very much, Dr. Wang. I really appreciate that wonderful introduction. And it's terrific to be here at your Data Day. Data, of course, is a really important characteristic that drives a lot of things, and I'm going to talk today on how it drives smart things, smart cities, and it's just become indispensable in the way that we live, work, and play. So I'd like to, let's see, I'm going to click over here. You should be able to see a screen. Can you see a screen that looks like a familiar city to you?
Yes.
Excellent, thank you. Okay, so I should point out that part of the work that I'm going to be talking about was financed by the National Science Foundation under a cooperative agreement. I'm associated with the University of Utah in the School of Computing, and I'm speaking today from my role, as you heard from Dr. Wang, at US Ignite. Okay, US Ignite, for those of you who may not know, is a nonprofit. We accelerate the smart city movement, so that's where smart comes in here. And we're really, jump to the bottom there, advancing technology research that we think is at the heart of smart city development. So that technology research, and particularly the data technology, is of significant interest. I was also the mentor for the Big Data West part of the National Science Foundation, getting their big data movement started. So I thought I'd make this a little bit personal and say, how much data is really about you? Have you ever thought about how many disk drives and solid state drives all around the world have your name and maybe your social security number and other kinds of things about you? How much data is really out there about you? So I decided I'd try to find out about me. But first, I thought I'd give you a little bit on terminology that I'll be using throughout the talk. So first, to measure volumes of data, a kilobyte is 1,000 characters or bytes of data. You get about 2 kilobytes on a page, a printed page. A megabyte is 1,000,000 bytes. A gigabyte, which I'm sure you've all run into, is 1,000 megabytes. And the English Wikipedia text is approximately 20 gigabytes these days. So that's, you can store Wikipedia on a lot of hard drives these days. Not the pictures, just the text. A terabyte is 1,000 gigabytes, which would cover all of my photos I've taken. I'm a photographer and I've taken about 50,000 photos. You can see about 30,000 of them on Flickr. And that would be about a terabyte. Now, 1,000 terabytes is a petabyte. And that's of interest because the human brain has approximately 2.5 petabytes of capacity to remember things. So if you're a student in your university education, use those 2.5 petabytes to go and acquire and organize some of the knowledge and practices and scholarship that is there at the University of Cincinnati for you. An exabyte is 1,000 petabytes, which would be all of the files that are backed up by one of the premier backups for home services, including me, called Backblaze. And a zettabyte is 1,000 exabytes, and we'll talk about that toward the end of the talk. There's also ways of measuring speeds to move data. So if you want to take a look at speeds, whoops, didn't want to do that. I wanted to do this, I think. There it is, speeds to move data. So a kilobit per second is about a dial-up modem. A megabit per second is about broadband. The Federal Communications Commission says 25 megabits down and 3 megabits up constitutes broadband. A gigabit per second is what Google Fiber introduced and launched a whole bunch of gigabit to the home projects, and that was really important there. And terabit per second is 1,000 gigabits per second. We'll also talk a little bit about time, where 1 ms is a millisecond, which is 1,000th of a second, and a ms, a microsecond, is a millionth of a second. So history of speeds to homes and small businesses for transmitting data. In the 1970s, I was one of the lucky people to have a TechAx card, and I could access this thing called the ARPANET, and at 14.4 kilobits per second. And that, of course, is about 1,200 characters per second. 1,200 characters per second, why? I couldn't even read that fast. This is as fast as I would ever need, 14.4 kilobits per second. Of course, I hadn't really discovered graphics yet. In the 1980s, we had dial-up at 28 kilobits per second, and then later, dial-up went all the way to 56 kilobits per second. But in the next 2 decades, the 1990s, the megabits per second to the home ruled. Cable was able to provide 10 megabits per second to the home, and there were 28% of all homes that by the end of the 2000s had a megabit per second. In 2010, as I said, Google Fiber really started a race to provide a gigabit per second to the home. And now there are a number of folks offering 10 gigabits per second to the home. One of them is Utopia here in Utah, and also in Chattanooga, Tennessee, and Westminster, Maryland. A number of places are now offering 10 gigabits per second. And the research that's going on right now is a terabit per second, 1,000 times a gigabit per second. But take a look at these dates and these numbers. In the 70s, kilobits. In the 70s and 80s, kilobits. In the 90s and 2000s, megabits. And then 2 decades of gigabits. So Glenn's postulate, you can check this out here in 10 or 20 years, is that speeds double every 2 years. And that we're going to see terabits per second to your home in the 2030s and the 2040s. That's my prediction. An interesting thing about this is that if you lay this on top of the famous Moore's law that says how fast computers get, it's exactly the same growth rate. This is a map that shows the terabit per second. The terabit per second links are these yellow ones that go across the country. A little bit more yellow. And that's something that's being done right now and is going to lead the way for future terabit connections, which will become more and more dense. And eventually, as I say, I believe about 2030 reach the home. So how about our senses? What can we do? Well, for people, eyes can take in about 10 megabits per second. And the skin is wonderful because it's got a lot of surface and it can feel a lot of things. And the skin takes in about 1 megabit per second. The ear is about 100 kilobits per second. Smell about the same, unless you're a dog. If you're a dog, the dogs take in megabits per second through their smell. And the taste about a kilobit per second. Our taste is our least capable in terms of transmission rate senses. So, as I said, I wanted to look at how much personal data there was about me. So I've got a hard drive at home. Hard drive holds about 10 terabytes. Okay, pretty good. So how much maybe does Google have about me? Well, everything they have about me is about 80 gigabytes. That's not my data. That's what they know about me and can tell me, and I can take out with things like Google Takeout, which allows you to download all your Google data. But I did run into this when I tried to do it. We finished creating a copy of the Google data you requested. However, we were unable to create a copy of all your files. You can still download your files until October 26th, but be aware that there will be data missing. In other words, Google seems to have lost some of the data they thought they had about me. Pretty interesting. I tried this same thing with Amazon. I thought Amazon might have a lot because I shop there. And they said, we've received and are processing your request to access your personal data. This was about a week ago. We will provide your information to you as soon as we can. Usually this should not take more than a month. So I can't tell you how much data Amazon thinks they have on me because I have to wait another 3 weeks before I can find out. Interesting. So here are some of the other numbers. I've got 187 websites who are storing stuff about me, according to my cookies. My browser has remembered 746 passwords, which means I must have gone to that many sites which required me to create a password. And I let the computer create my password so that no two are the same. And the number of authenticators that I carry around to either go and click and look at the numbers or go to my phone and say, show me in Duo Mobile a new 6-digit code is 6. I've got 6 of those authenticators, one for Microsoft, one for Google, one for E-Trade, and so forth. And of course, there's a lot of continuous reporting going on about me. So this thing is a great tracker. I've told Google it can keep track of my location, and that's very helpful to me because I'd like to know how far I've gone on some of my runs and where other things are. So I allow them to do that. And then using the watch here, this is a Fitbit, I guess it's a Fitbit Versa. My heart rate is currently 62, it says. It's keeping track of my heart rate, steps, floors climbed, distance traveled. I'm in a trial with them to see if my watch can detect atrial fibrillation. And it also reports things like my oxygen saturation. And my presence is detected by smart speakers and devices from both Alexa and Google I've got throughout my home. They realize when you're there. Google has just announced in the past week that you can now ask Google to remind you of things when you come home. And the way they do that is by sensing your presence in the home and then telling you that. So Alexa and Google are not just listening to you, they're also looking for your presence. I also check to see on my home internet usage, and I don't watch television, made an exception for the debates last night, but I didn't count that here in the data. And during COVID-19 anyway, I have about 6 gigabytes going to me and about 6 gigabytes going up per day, for a total of about 12 gigabytes per day, which is interesting because, of course, during COVID, I'm on a lot of Zoom calls and other things which have as much data going up as it has going down. So it's actually kind of balanced for me. This is what it looks like nationally. This is what the National Cable Television Association members report as peak consumer usage and the growth due to COVID. You can see that the growth averages about, looks like about 15, 16%, but they also have statewide data. And I looked up Ohio since you guys are in Ohio, and they had that's the second highest state after South Carolina at that 24.2% growth. So you guys must be doing really well at using electronic means to supplement. In terms of upstream, the growth is even more dramatic because this means, of course, images from your home are going out. It's not just people who are using Netflix. And so we see here 35, 37% growth in that data leaving the home, heading out to the internet. Microsoft says that they've had a almost 8 times increase in cloud service usage in regions with social distancing and shelter-in-place orders. And Amazon Web Services is saying there's a 70% year-over-year revenue growth in that use of the cloud. So it's fortunate that we had a very expandable cloud and expandable networks that were able to accommodate this kind of dramatic growth in data. New York Times took a look at some websites here, and you can see that when the COVID-19 hit, that's the vertical line there, that things took off in terms of Facebook, people socializing via Facebook instead of in person. Netflix went way up, YouTube went way up. But in terms of apps, portable mobile apps, not that same kind of dramatic change. So people are definitely using laptops and tablets at home as compared to putting most of the increased usage on their cell phones. Video chat has gone way up. Google Duo is now the way I keep in touch with my grandkids. Nextdoor.com, House Party, of course, has been just a terrific winner in this. And things like Zoom is that top line there, Google Classroom, Microsoft Teams, they've all been very, very successful in having additional traffic and data. So that was kind of my personal data story. And now I'd like to kind of turn to data-driven smart things. Well, what smart things? Which one should I do? So I decided to type in smart into Google and see what the completions would be. And here's what Google says smart completions are. So smart city, smartphone, smart speaker, smart thermostat, smart kids, smart food. I'm not sure smart food fits with the high tech, but that was one of the things that Smart came up with. I also think it's interesting which ones of these have the word smart concatenated to the name and it becomes one word. like smartphone and smart food, and which ones are still separate adjectives, smart thermostat and smart speaker, digital assistant. So let's go and take a look at the smart autonomous vehicle. That's a new one out of the UK that you see there toward the bottom right. And in that case, that smart vehicle up to the right collects about one, I can't quite see it here. Can I make this make myself a little smaller? Maybe make myself a little smaller. Okay. Collects about 1 terabyte per hour of operation. 1 terabyte every hour of operation for these vehicles. And that's because they have more sensors on them than we have. They're collecting more information at a higher rate, and they're more aware of their environment than people are, which is probably one of the reasons that in the end, they'll be safer than having human operators at the controls. They can just watch and collect more information about what's going on. But that data, of course, is going to be monetized. If you look on the left, you see that McKinsey and Company has a whole report on how to monetize car data. New service business opportunities to create new customer benefits from monetizing car data. So it's very interesting. Once we collect data, the data itself has value, not just for the reason it was originally gathered, which was to give you a safe passage in an autonomous vehicle, but there are other uses of the data that go and have that value be intrinsically valuable. And that's one of the key points I wanted to make, is that data has intrinsic value beyond the use for which it was originally collected. Okay, I confused the slide advance. Oh, and one of the big questions is who, let's see, who owns the data generated by your smart car? That's a really interesting question. And in most cases, we're seeing things like Tesla says, they own the data that's coming out of your car. You don't. You're getting a vehicle, but all of that secondary usage data, they can monetize. And that's going to be very interesting because it allows the car to cost less, but it also moves some of the profitability of owning a car to the data collectors who originally put that there. Okay, so personal data. I wear the smartwatch I showed you earlier. It's showing my SpO2, my oxygen saturation here at 95% for last night. You can only gather it during the night for reasons that are unclear to me. It has to do with the variation in the oxygen level. And I designed my day around getting enough exercise and doing something besides just sitting behind the computer. So you can see here that I've got lots of statistics, data on my personal day, how it's going. I can put in how many calories I'm eating. It's tracking my heart rate. It's tracking how much I'm moving, how long I slept last night, 7 hours and 24 minutes. And all of those things help me to do a data-driven personal life. Now, one of the things I do to exercise is I go and I kind of climb the hills behind my house. And you can see in the middle there, let's see, I can do that. So this red track here that I'm highlighting in yellow is my running route. I live right there at the bottom, and then I run up here and run over there, and then up here is a very nice view of all of Salt Lake City. And you can see I do pretty much the same run every day. So very interesting, collect some data. It also thinks I did some outdoor biking. I didn't. I do have a bike, but I didn't do any outdoor biking. It just inferred the wrong information from the data it was able to collect. So the inference isn't always right. And over the last 2 days, these are the maps it gave me. I swear to you, I did not go and run from my house into and through the middle of Salt Lake International Airport. That did not happen. And it thought that happened on 2 consecutive days. Those 2 days, I actually did run the same kind of backwards question mark that you see in the middle there. But the data isn't always right. It doesn't really know. And this is 2 days in a row that it got that wrong. Interestingly enough, the mileage is about right. 5.24 miles is about right. 5.21 is really close. 4.94 isn't that far off. 5.24 here. So how it got the right distance and yet had such an incorrect GPS track? Well, data is not perfect. Amazon is discussing the ways that it's monetizing Alexa. So it's not just listening to you. Of course, the reason that the Google Home and the Amazon Alexa devices are comparatively inexpensive is that they really are giving you back some of the cost of the device from the monetization. And for Amazon, it's a direct monetization. They think that with an Alexa in your home that you are going to buy more things from them. It's going to be easier to buy. You're just going to be able to tell your Alexa to go buy something. And good thing there's none in this room. And those things will just kind of arrive. So that was kind of personal things. I want to talk about smart cities because, of course, I work a lot in smart cities and smart city activities. So growth of smart cities, there's a lot of things that we do. So smart cities can have a number of capabilities like smart and connected communities, autonomous vehicles, continuous health monitoring. I think the watches are just the beginning. Smart digital assistants, just-in-time education, looking at cybersecurity for communities and smart workspaces. And I thought I would just show you a few of these applications. Maybe I'll come back to the slide and I'll come back. No, I have to do the slide first. Okay. These applications require very fast response times. And the very fast response times we talk about in computer science as low latency. Low latency. It's very fast in responding. And we need that for a number of these applications. And I'll talk about that. They also need to be high bandwidth. We need to get a lot of that data through, just as we were talking about in that growth. And the bandwidth is needed for augmented reality, virtual reality, artificial intelligence, machine learning, and lots of other big data applications. The latency is one of the things that we haven't really focused on. We've talked about, I have a gigabit to my house, but we haven't talked about, do I have a millisecond to my house? We need latency that can converge on human response times, mechanical and chemical response times, electromagnetic response times. And of course, all this is limited by speed of light. We cannot go and get any faster response than speed of light allows us to, which means that a lot of the things that are now in the cloud are going to have to become more local into our communities. We're going to be coming into downtown Cincinnati because we don't have the time to send it to a distant data center just because of speed of light, not to mention all the other things that slow it down. So here's a chart that has a logarithmic scale here. We've got 10 seconds on the right. We've got a tenth of a microsecond on the left, 100 nanoseconds. And in between, we've got everything else. So humans can detect a difference in simultaneity down to in the range of 7 to 10 milliseconds. That's really what people can do. So things like serious gaming, human remote robotic control, haptic telesurgery, all of those things are going to be in the 10, 20, 7, 10 millisecond range. For 5G, they're going to be able to push it down to a tenth of a millisecond. So down here, just past this next line. And to be able to control the power grid, vehicle motion control, I'll talk about that in a moment, you need to be moving to the left. So as the data is going faster, the latency comes down and moves to the right across this chart. Data that doesn't get there in time perishes. It's like you don't eat your ripe peach and it gets mealy. So the value of the data decision making to do something right now, for example, drive an autonomous vehicle, decreases over time. To be actionable, to be used for machine language recognition, cyber physical systems, you need to have a time delay. I'm delivering that in the millisecond, sub-millisecond range, and the value goes down as time goes on. After a while, you can no longer make an in-time decision about that, but you can use it for machine language training or for historic purposes. Microgrid coordination is one of those. Microgrid is balancing the power generation with the power usage. There are these things called laser measurement units. They have to be accurate to within 32 millionths of a second, and you have to be able to react to any changes in the grid in less than or equal to 10 milliseconds. If you're platooning 4 trucks together, as you can see here, you need to have time accuracy very small. If that first truck sees something and needs to brake, the other 3 are going to run into it unless they brake simultaneously. They need to react in very neatly without running into one another. You're going to have autonomous intersection management and again react in less than 10 milliseconds to make that work. In the case of an earthquake, we first get a notification called the P wave. The P wave arrives here, and then you have a number of seconds. It depends on how far the epicenter of the earthquake is from you, but in this example, it's about 7 seconds. About 7 seconds before the damaging shear wave arrives. There are things that you could do to save lives and be able to make sure equipment is not damaged with earthquake prediction notification, where fractions of a second really count. So US Ignite is working with a number of 8 CIOs in cities and 8 companies to develop a smart city data catalog specification. And let me get back so I can advance that. And that is something that you might want to look at if you're working on smart city activities. I'm going to leave it just at that, given the time that's left. So data drives smart research and learning. And I thought that George Turner's session earlier today really demonstrated that. But it's really a 4th paradigm of science. We originally started with empirical science, observing the real world, doing experiments. And then we added to that theoretical science. And you can see Maxwell's equations there. How are the physical laws represented mathematically? And then we discovered only a couple of decades ago that we could do computational science by doing simulations of what we're seeing. And now there's a 4th paradigm, big data-driven science, where the data, artificial intelligence is really driving what's happening. The Square Kilometre Array in South Africa and Western Australia, they're putting out 132,000 antennas. In Australia alone, they're generating 157 terabytes per second, which is about twice the global internet traffic. We're going to triple global internet traffic when this thing comes online in about 5 years. Deep brain stimulation tuning. This is a project that we worked on with the University of Utah. We're visualizing the synapses in the brain as stimulated by deep brain stimulation tuning here. Data drives artificial intelligence and machine learning. Aaron McCabe gave a great session earlier today. I hope you were there. You can go and create these neural networks that have input and output layers and recognize things. This is becoming a very important way to be able to take inputs and have the machine figure out what are the distinguishing characteristics and to be able to recognize them later. And there are a lot of safety systems being built on this machine learning. You get machine learning systems to decide what's safe and what's unsafe, so that you can make sure that there are systems looking out for your own safety. One thing we know, in the data-driven world, it will always be on, always tracking, always monitoring, always listening, and always watching, because it will always be learning. It's kind of the point that we were making with Alexa and Google. But things can go wrong. There's some things that have gone wrong for me. My medical record says I have several ailments I've never had. It apparently occurred when they went from manual records to electronic records, and they can't fix it because that would be a violation of medical record keeping law, which says you can't get rid of anything. My identity has been stolen. I now have a 6-digit number for the IRS to be able to file my tax returns. I've had Google lose information for me. And there's lots of stuff that could just go wrong. The IRS has been investigated for using location data without a warrant. Normally that would require a warrant, but they've discovered they can buy it from a third-party location service. And by paying a third party, they can get around the current restrictions on not accessing location data without a warrant. I'm going to skip these slides because I think you understand that data can go all the way from helping understand concepts to being misleading, from comprehensive to being taken out of concept, from being secure to being stolen, kidnapped, and ransomed, from being clean and accurate all the way to being wrong. I want to finish up by saying data drives smart economies. This is the number of interactions per capita per day we have with our data, according to Seagate and IDC, which measures these things. About 1,500 a day in that next to the last column for right now, and going up to about 5,000 a day in 2025. The annual size of the global data sphere, 175 zettabytes. Zettabytes, that's thousands of exabytes, which is thousands of petabytes, which is thousands of gigabytes. How much of this global data sphere is real time and increasing percent? Remember I talked about perishability. Now it's going up to about 25, 30% of all that data is real-time data, where that makes the difference. American companies alone are estimated to have spent over $19 billion in analyzing and acquiring customer data. And the data broker industry is believed to be worth about $200 billion. The gross data domestic product per capita for the United States is about 30 terabytes of data per person. 30 terabytes of data per person is how much a single person creates for the data economy. And you can see that we're behind some of the European countries and ahead of a lot of others, but China is number 2. There's more data being created per capita, even with their huge population. And that has a difference. The dark bars here is the amount of gross domestic product we take into account economically. This additional piece up here, the light blue, represents the data part of the economy, which is now not being measured by our Department of Commerce. And it's real because it creates values to the economy. I'm going to skip Project Overcome and just say, data drivers, drive a smart you. There's a picture of some of the axons connecting inside your brain. There's your 2.5 petabytes. What will you do with your own data economy? Thanks very much.